Hi again, everyone. Professor Sebastian. We're returning to our section 14.1 Calculus 3 class notes. And shoot, I forgot already. We are on page 44. Okay, so in this section, in section 14.1, we're talking about functions of more than one variable. Okay, so first of all, a couple definitions here on this page. We want to consider a point, x naught, y naught, in a region, some set, R, we're going to call it, region for R, in the xy plane. So think of the following two types of points on this region. We have interior points and we have boundary points. And the way these are defined as follows. An interior point is a point that is the center of a disk of positive radius. So if you can draw a positive radius disk around the point, and that disk lies entirely in R. So this could be really, really small. This point could be really up close to the boundary, but not quite on the boundary. You still would be able to find a small radius disk around that point. That's an interior point. Okay, a boundary point is a point such that any disk that you try to draw around that, one side of it's going to be out of that region. Okay, so a boundary point is a point such that every disk of positive radius for which it is the center contains points outside of R as well as points inside R. Now, an open region is a region that only has interior points, right? It's like this region would be, you can imagine like a dotted boundary on this region, which typically indicates don't include that, right? So if that's the case, then this would be a open region. A closed region is a region that contains all of its boundary points. Okay, it contains all of its boundary points. A bounded region is a region that lies inside a disk of finite radius. Though the whole region would have to lie inside a disk. In other words, these regions I drew, this example region here, certainly is a bounded region. You can find a disk outside of that region. An unbounded region is a region that is not bounded. Okay, it's not bounded. Now, as an example, go back to our function that we talked about on the previous page to find the domain. I just want to get a little bit more precise here. So we have f of xy, or z, equals the square root of y minus x squared. So we said, well, what's the domain of this? So again, the natural domain is just that this, whatever's inside this square root has to be positive or 0. So y minus x squared has to be greater than or equal to 0, which means y has to be greater than or equal to x squared. Now we know what y equals x squared looks like. It's this parabola. Okay, so y equals x squared is fine because it's for y greater than or equal to x squared. That's in the domain. So this is the boundary. Okay, so anything that lies on this parabola, now this parabola shoots out to infinity, right? Anything that lies on the parabola is a boundary point of the region. And since we have greater than or equal to, this is actually closed. Okay, it's a closed region because we include the boundary points. It's not a bounded region, so this is a closed, unbounded region because this goes off to infinity in this direction. But it is closed because it contains all of its boundary points. So the interior points are where y is greater than x squared. Any point where y is greater than x squared is an interior point.